Hi everyone, let's look at what these power tables are all about. And then at the end, I will talk about what I actually expect you to get from these. So this first table is looking at one sample for a two-tailed alpha. That just means that it's not directional. So we don't care which group is higher or which group is lower, or if it's different. We just care if it's different. Sample size is given right here. And we also have effect size, so small, medium, and large. This can get a little confusing, I know, because it depends on the table and it depends on if you're using G-power or who you're quoting is really who it comes down to as to what they consider a small, medium, or large effect size. For these problems and for this learning in this class, just go with whatever they're telling you. If it says small, here it's a 0.2. If the problem gives you a 0.25 or a 0.3 and calls that small, then just make the adjustments. Everything in here is our actual power that's achieved. So if I have a sample size of 10 with a small effect size, I have a very small power. If I have a larger effect size with a sample size of 10, I still don't really have adequate power. I need at least 15 to get to my 0.7 for adequate power. Scrolling down to our next table, this is doing the exact same thing, except now we have two groups, and these groups are independent. That means that the people in the groups are different. You cannot be in the same group. This is not a pre-post. This would be like male, female. You have to choose. So we have our sample sizes for each group, and then the same, so small, medium, and large effect size. If we scroll down, if we have a small effect, we have to go quite a ways to get to that 0.7. We would need a sample of 300 in each group in order to gain adequate power. If we go back over here to where we have a medium effect size, to get our minimum power, we need two groups of 50. So within a larger effect size, we don't have to have as many people. And this gets even more pronounced when we have a very large effect size. We can drop to about 20 to 25 in each group. Sorry, my dog just woke up and is being loud again. In table 3, we are looking at correlation effects. So this gets a little bit strange, and we're not going to go in depth here. So we have differing effect sizes for correlations, and then number of pairs. This is not a very helpful table. G-power makes so much more sense if you're doing a correlation and wanting to know effect size and power. So here we're kind of doing a different idea. So in this table, we have our desired power, so we want at least a 0.7, and then it's giving us our sample size that we need, depending on if we have a small, medium, or a large effect size. This is for one sample. This is doing the same thing for two samples, again, independent groups. So it's telling us what is our desired power. We can hopefully go to at least 0.7, and then depending on if we have a small, medium, or large effect, how many people do we need in each group? You will see that 50 is kind of a good number for each group, but at least 20 to 25 is needed even if we have a large effect size. This is further compounded by the type of analysis we want to do, which we'll talk about a little bit. This is doing the same thing for correlation. Again, this gets really messy, and G-power is so much easier for correlation. And then one-way analysis of variance. Here we have multiple groups, and this is telling us the group. This is telling us the sample size for each group. This is saying if we have two groups, small, medium, or large effect, 3 groups, 4 groups, and this would be the actual power that we can achieve. So let's look at if we have two groups and we want a power of 70, then we need 20 in each group. Over here, sorry. Over here, if we have 3 groups with a large effect size and we want a power of at least 0.7, then we need 20 in each group. Same. And over here, same thing. This does change, of course. So go through and kind of pick a couple of groups and how many would be in each group, and think about how it changes depending on your effect size. Same concept, we just get bigger groups. Now looking at what I wanted you to do for your homework. Questions 1 and 2, first of all, change that to a 0.05. We don't have a table with 0.01, 99% confidence, everything's 95. All I want you to do for these is just compare a few. So go to one of the charts, probably one of the first two will make a little bit more sense. So look at 1 sample or 2 sample and just compare. The whole purpose of this week is for you to understand the relationship between power, effect size, alpha, and sample size, and to know how to go back and forth between all of those. For the homework, I did make a change that you can actually use the tables. I added in a sample size of 100, and this is for one group. I hope that this helps. Email me with questions.